the next, I would like to show you very quickly of the application of the technology, information technology. So far, okay, everyone from the start of this class already learned how to understand the principle of the sensor, okay, from the different mechanical, electrical, sound, optical, and then the second part you already learned what is the 3R, and also how to you determine your requirement from this 3R: rate, resolution, and the range, right? Okay. And third part, actually, right now we are doing the final project, so everyone, I supposedly can use the Arduino for the monitoring in the practice. So we use the NCU slope as a case for your final project. And the previous one, we already show you some of the idea of the wireless transmission for the monitoring. Okay. Oh, sorry. Between that, I already show you how to interpret the data with some of the quantification methodology. Okay, you can quantify the data with the regression or some of the envelope. Okay, regarding the different issue. So you guys, you can think about from this class what you can learn from the first beginning of this class to the data interpretation, and now for the new technology with the LoRa, and now I'm trying to introduce the cloud computing and also the web-based platform. The purpose is try to deliver the message of the monitoring with this information technology. So here I would like to give you some of the idea of the structure in the information technology and the web-based platform. So the first question I would like to say, what is the cloud computing? Actually, the cloud computing, this term is very popular, maybe 4 or 5 years ago. Okay, but right now it is replaced with the AI, artificial intelligence, or the machine learning or deep learning. Okay, but I would like to say, if you try to apply the cloud computing, you need to understand 3 types of the typical structure for the service. The first one is the infrastructure service as a service, and what we call the IaaS. IaaS. Okay, so for the infrastructure as a service, you can manage your own application and also the runtimes. I mean, some of the programs, and also you can take care of the security and the integration of your software. Also, of course, you can build your own database. I mean, if you have some of the purpose, try to have some of the computation with a PC or a laptop, and for the infrastructure as a service, the great one, they already provide this service for you from that platform, but you still need to determine and manage it, the blue part. But in the next, this is another level, what we call the platform as a service, PaaS. Okay, all you can do is build your own application. I mean, you can rent a website or the virtual machine from the Amazon or the Microsoft. They already provide by the vendor with the hardware security, maybe the OS. You can rent a different kind of the memory and OS by yourself. Okay, and then you can upload your own program and application if you already write a Python code or some of the Java application, okay, so you can do that. Use this environment and run your program or application. Or otherwise, you can use the software as a service, totally including the application. You can rent from the vendor. So what is the example? Can you suggest what is the typical example of the SaaS, the software as a service? Anyone? Google? Yes, Google Map, Gmail, or Calendar. This also the application included by the provided by the Google. So everything Google already provide, and all the service you can use. So this is a software as a service. So I would like to say these three types, you can choose what you want and what you already developed. So for this kind of, I'm sorry, it's in Chinese, but I have a quick translation. For this kind of the commercial platform, including the IaaS or the PaaS or even the SaaS, okay, you don't need to buy your own computer. I mean, you just rent an environment, and all this environment are maintained with the company, commercial company, okay? But however, you need to check out the functionality of this environment first. I mean, what kind of the computation capacity you need, okay? For example, how many CPU you want, how many memory you want, how large of the disk you want. You need to define first. Everything already provided by the Google, for example. So actually, you just only can use the application they already provide. But based on this idea, I would like to introduce some of the monitoring software example for you. The first one is the Argus monitoring software. So what is that? This software can be divided into two types. The first type, if you have your own PC and if you have your own data from the monitoring, this software provides a server and a database in your computer. So you can process the monitoring observation, I mean the data, into the server and the database, and for the demonstration and the visualization through the internet. So this is actually the interface of the Argus. So they're using the web server to provide the web, and you can find this is the Argus server. So right now, I think this company provide the two kinds of the option for you. One is you can build your own hardware and install the software provided by the Argus, or you can directly rent all the service on the internet. Okay, so just like the Google or the Amazon, you just pay and rent the service from the Argus. So actually, always the web-based interface, you can have a login with the administrator or the guest or some of the user, and then you can build your sensor. And by the way, I would like to say this is another knowledge. for the communicate, especially for the data communication, for the data communication, because everyone, I would like to say, if I already have my observation of the monitoring, yes, if I have my observation, especially maybe for example in the NCU slope, so maybe I have a temperature, I have the ID, I have the name. So what else attribute you need to build for this sensor? The time, the location, or maybe the coordinate, or some of the calibration formula, or some of the function. I would like to say everyone can give any kind of the attribute to the one sensor, right? So how to define this attribute is very important. If you try to manage it, if you maybe you have more than 100 sensors in one project, or even you have so many projects with thousands of the sensors. So the attribute, some of the information is very important, and each one is unique for the sensor. I would like to say, if I have my own A company, and if you have a B company, if you have a C company, your own C company, and I have maybe 1,000 of the sensor, and you have 10,000, you have 20,000 sensors so far. And one day the government said, okay, A, B, C, because your funding is from the government. So all the sensor, all the observation should be open in the internet, and everyone can access your observation directly. And each of you should be, give all the data to the government, and have some of the documentation for the public. Okay, based on that requirement, if you don't have this very, in detail attribute, actually A or B or C will not understanding the information from each sensor. Okay, because I have my own descriptions. B, you have your own descriptions. C, have your own descriptions. So, but however, I cannot understand B or C. You will not understand A or C, okay, either. So this is the problem. And there's another issue regarding the open standard. This is another issue for the sensor, but I think maybe later or in the next time I can show you some of this kind of the open standard. And you can check out the keyword. Right now we have a very large OGC. Okay, this is an organization to define this kind of the open standard for the data, what we call the interoperability. Okay, so this is another attribute of provided by the Argus. So let us see here. You can find this is just like your Arduino data, right? You may have your date, time, and value 1, value 2, and separate maybe by the common or the semicolon. Okay. So I would like to say, if you receive this kind of the data, how can I know what is the meaning of actually this value it is? I don't know, actually. if you cannot release some of the documentation or the manual. I will not understand the meaning of these values. Okay, so this is the one issue, and if you can define all the attribute and format, then you can have a processing of this data first. So you can parse the data by yourself, or parse by the data by yourself. And for the different time of the observation, what we call the time series, and you can use the data presentation or the visualization with the plan view. So here, maybe this is the strength of this concrete dam. Okay, and also you can have some of the information regarding the slope stability. So this is provided by the Argus, and also you can define your own threshold for the alarm, right? Alarm level from the green one, red, yellow one, and the red one. So you can define by yourself with what? Right? How can you define your own alarm level? How can you? Anyone? Can someone give some of the example? Maybe in my midterm exam, we already show you the example from the reservoir, okay? So you can compare the water level and also the leakage. So you can define the threshold with maybe 3 times of the standard and also the boundary. Okay, so the boundary may be the red alarm level, the 3 times of the standard. Okay, so if you have a lot of data like this one, you may have a linear regression and also some of the confidence area, maybe 90% or 95% of the confidence. Okay, so this is maybe the yellow one, and for some of the very large envelope, you can define as the red one of the alarm level, right? Okay, so with this, we can show you how to determine the alarm by the continuous observation. So here you can find this is the plot from the continuously, and also you can have some of the correlation plot. Just as I said, maybe this is the water level and this is the leakage, right? So we can have a very quick comparison between 2 observations, and also you can have some of the profile. What is this? Anyone can guess what is the result of this? We already show you on the midterm project. If this is using on the slope, used on the slope, what is that? Inclinometer, yes. Okay, so you can plot the data of the inclinometer in a different time with the Argus. So I think this is a very useful, and right now this is the basics of the requirement for the data visualization. And of course, you can have a report directly and automatically. Here, you can set your own alarm. And the second one, I would like to show you a platform from the monitoring point company. Here, you can say, if I have the sensor connect to the data logger, This is a data logger, right? And have a text file for some of the in the ASCII code file to the monitoring point service. So it will be like the August, and you can find the different level. You can rent with the different budget, rent with the different budget. Okay, and of course you can exporting the data into the Excel and have the graph data for the visualization. I think I just have some of the example of this software or the platform for your understanding that how can we show and collect the data, show the data, and have the very quick alarm based on this information technology. Okay, so this is the plain view. So you can find the blue one is okay, but with the red one, maybe there's a problem. The data already behind the threshold. So you can find here, this is the range of the level 1, okay. And this is the range for the yellow one, and this is the range for the red one. Okay, so you can define your own alarm by yourself. And the third one, I would like to introduce the Vista data vision for you. Okay, and of course you can, because this is a commercial one, you can have your own client level with a different budget. Okay, and also it can provide the standalone environment or the SaaS service. Okay. So here, this is the result of the main function for the data visualization. And also you can use the Google Map if you have a different project all over the world, or you can have the management on this. So this is a very quick video for all of you. Oops. Let me check. Okay. This is a very quick show you the application of the data Vista. Okay. Sorry. Okay. And for this Vista, they use the dashboard, a new technology of the dashboard. So you can track and design your own visualization or the plot by yourself. And you can configure each probe and the sensor by yourself. And this is the dashboard. You can add any kind of the observation with the dashboard by yourself.
As you can see, it is simple to add in and create new dashboards. You can create a new dashboard for each project and customize them as needed.
Okay, so this is the dashboard provided by the Vista company. Okay, and let us to check out the. I just quick show you the configuration. You can have your own different kind of the attribute, especially here. You can find this is the coordinate. You can directly build the coordinate for each sensor. for each sensors. And also you can have some of the data pre-processing. Okay, if you have some of the gap, this software will directly fill the gap by the setting. Okay, and also the alarm and information. Okay, and okay, this is the dashboard I already show you. And here, this is the fourth, the ENA system technology in Taiwan. So not only the information service, this company also provide the data logger directly. Data logger, okay. So you can combine any kind of the sensor and use this data logger. You can rent or buy it, and of course combine with the SenseLink. This is the platform provided ENA system. And this software you can find here. This is a structure, and also they use the MQTT. Okay, for the core technology. Why? Why they use the MQTT? Because they try to use this MQTT to deliver the data into the different distribution. So anyone or some of the sensor node, I mean module, or the people, I mean not only the person. If you have a system, try to share the data from the ENA system, you can subscribe the topics from the MQTT inside of the ENA system. So it is a very easy way to broadcast the information to the different distribution or the client by the MQTT broker. Okay, and this is, I think, in the detail I don't want to. And also, right now, you need to understand this is a very typical web service, what we call the RESTful. So you can use the HTTP request and for the web service, and then they will give you the response for your request. This is what we call the RESTful protocol of the web service. So the MQTT will be the same idea. So you can have the server for your the requirement, and have the request, and then the HTTP, I mean the server or the service, will respond your request. Okay, so I think right now here, this is the typical and the basics of the information technology, especially for the web-based monitoring service. And also for the ENA system, I think not only the map, you can show the map. For the ENA system, they also provide the video integration. So far, for the previous one, they just show you some of the observation from the typical sensor, right? Maybe the water level, temperature, or something else. But for the video, if you can capture the image or video, you can also integrate that information of the observation into the ENA system. Okay. So here, this is the web link of the ENA system, and it provides a trivial one. You can test by yourself for a very short period of the time. And I would like to show you the next some of the web page. So everyone, guys, in the next week, just as I said, please, everyone, you need to prepare maybe 5 minutes of the presentation. You can find any kind of the monitoring website, but not repeat of mine. Okay, you need to find your own and a new one. Okay, so just quick introduce what is the website and what is the maybe some of the advantage from the monitoring website. Okay, so the first one here, I would like to say this is the sensor cloud. You can transmit the sensor observation by yourself for the data storage, visualization, and the management from this sensor cloud. And you can find here, this is the visualization from your data. And this is the very quick introduce of the Sense Cloud. Sense Cloud. No more sound. So this is a platform, provide a service that you can integrate all the observation from the different kind of the data logger or the sensor. And it is just show you the interface. You can create your own channel and your own the visualization. Actually, it is like the ThinkSpeak, the ThinkSpeak. Okay, but maybe it will have a complex function you can use. Okay, so I just quick have an introduction of this. And the next one, this is the National Ecological Observation Network, NEON. Okay, and for this is provide ecological monitoring data in the field. So including the atmosphere, the organism, population, communities, and eco-hydrology, and biogeochemistry, and also the land cover and the process. So provide so many topics of the data observation. So maybe you can check out, and also have the map. And for some of the coordination, you can determine the location you want and capture your interested sensor or the data by yourself. And the next here, this is G0V, especially for the air pollution monitoring in Taiwan. So this is the PM 2.5 observation in the Taiwan in a different place here. Each dot means the coordinate of the sensor So here you can find, this is an example in the Taipei city. So you can check out the time history and air quality in the real time. Okay, so this is an example for you. If you try to introduce some of the monitoring website, this is a G0V, air pollution monitoring service. Okay, so this is a time history. If you click on the dot, it can show you the time history in this day. Okay, and also this is the picture. I'm sorry, here they didn't give you some of the data topic. This is the windy. Windy is data from the America, and show you the some of the very basic information at the atmosphere. Okay, so you can find the wind direction, wind blow velocity, and also the rain and temperature. Okay, and here including the ocean information with some of the very typical observation. And the next, I would like to introduce some of the geotech, especially for the inclinometer. Oh, sorry. Okay, and this RST is especially for the geotech sensor application. Okay, so you guys can use this software to retrieve the data from the inclinometer and have a very quick visualization of this. Okay, so this is a service provided especially for the inclinometer. Of course, you can combine the borehole, so you can definitely define the layers: CLT clay, gravel, sand, and the gravel sandy silt, and the sandstone in each layer. Just like in our slope, we have a borehole, and we already know that maybe under the 30 meters, there's the rock interface, And this is another case for the farmland. Okay, the pollution of the water quality. Okay, so this is in the Taiwan website. Also, you can find some of the data visualization and real time. And this is the farmland, another field showing the map of the different usage. And this is the offshore information, including the wind, the ocean, and the water temperature, and the tide, and the level, and in a different location around the Taiwan. And this is some of the EPA, Environmental Pollution Agency. Okay, so they try to capture some of the pollution source from the industrial area. Okay, and also the temperature pollution. This is from the EPA, the government agency. Okay, and this is another one, the iEnvironment. They provide the app here like this to have a quick monitoring based on the EPA observation. And of course, right now the project we use the ThinkSpeak. Okay, so guys, is there any problem so far to connect the ThinkSpeak? If you try to use the 24 hours using NORAD to capture the MQTT and send the data to the ThinkSpeak, I know that one group already build a program, and also you already build a program. 你们这边呢? All about you. You need to quickly show, because I need at least 2 or 3 weeks data. Okay, at the least. Huh? The LoRa is still not working. Excuse me. The LoRa is still not working. The Rusty? The LoRa. Not working. This time? Yeah, I put the thing 2 weeks ago, still no data. No data? Really? So right now it's still have the capture the data. It's working in the box, but nothing. Not respond in MQTT. No, not yet. Open you. But in the last time you said you changed to the small the short cable. Nobody changed. You can change by yourself. Okay. So I think you can ask the rig if you need a small cable. Okay. But somehow you need to check by yourself. And let me check the so this is the website of the LoRa gateway. Okay, I put the LoRa gateway in the roof of this building. But in the last time, you already replaced the shorter one, right? Not yet. The shorter cable, no? So for the other station, not yet. 你们去装了没啊？你们要有3个礼拜的资料哎，到6月底哎。我们7月3号不是要7月初要 present 啊？你还有一组嘞，你们那一组也都还没啊？你们 sensor 都弄好了吗？还在做啊？你们要加紧脚步哎，不然我是会真的照大家的表现去打分数哦。这个就是占一个很大的比例啊，25%25%。Okay, so maybe later you can check if it is another short cable. Okay, for the I think you just try to short a cable from the Arduino to the antenna of the LoRa, right? So maybe 50 to 30 to 50 centimeter is enough.
There are cables in the lab?
Yeah, I think I have some cable in the lab. Okay, but in the last time you already have the change.
So
not yet.
Put to the.
You just check.
We just didn't put cables. We just directly put on the antenna. But then in the box, just outside of the box, we just to try that.
Okay.
Even this, we just received like once, like maybe 10%.
Only 10%.
Maybe less. I don't know. We just received 2 or 3, and then no more. So I'm not sure it's the cable. Because before the people were the other students last year were using the same cables and it was working right. So I don't know. Maybe it's not the.
Okay, maybe I will ask Rick to help you to resolve this problem. Okay, but make sure that you can transmit your data.
We receive 100% of the data.
Yeah, because you just a very close gateway just in the roof of the. But of course, because in the last year, my master student also tried to use the LoRa, and he said maybe up to the 80 to 90% is okay. So I think because he already proved that he can transmit the data from the MQTT, so I think we can repeat again.
I tried to put the SD card in the same time.
Oh, yes.
There are problems in the pins.
Okay.
I don't know the name.
SDA.
Yeah. This one goes in the same one as the LoRa.
The LoRa.
So we need to.
But you can change. You can change to LoRa to the another pin, because in my example I use 7 or 8 for the LoRa. One is the transmission, the other is the RX and the TX for the 7 and
but it uses like the number 4 as well.
Number 4.
But there are problems in the right. So
I think it is maybe okay for the LoRa. You can check the DIO. We have so many DIO, right? To the 1 to the 13, right?
Yeah.
So for the LoRa, in the last time in my example, I use the 7 and the 8 for the RX and the TX. So we just use the 2 pins for the LoRa transmission. So you can assign anyone, maybe 1 or 2 or 3, 2, 3 or 3, 4. Just a pair of the pins you can use for the LoRa transmission. You can try again, because I know
there is problem with the SPI connection.
SPI you use for the no, I don't know. The LoRa didn't use the SPI. It just used the DIO pin. So you can directly assign any 2 of these 13 pins LoRa don't need to use.
I think I tried, but on the internet they say that there is you can't.
No. Okay, maybe you can.
And then I tried to connect another Arduino.
Yes.
But you can as a slave of the first one, but the real-time clock uses the same port as the one we connect to Arduino.
Mm-hmm.
So you cannot write on the same time on the SD card and receive the real-time clock data, because there are conflict between the writings and the receiving, because it's on the same port. The A5.
A5.
Yeah.
Oh, you mean an analog?
Yeah. To connect
analog
to Arduino,
1 to the analog 5.
To connect the Arduino together, we need the A5, and the RCT need the A5 as well.
Oh, you can change if you have another space of the.
I tried, we cannot change.
You cannot change to the A1.
So the A5 is special.
Really? You have the same problem? Maybe you can try, because I know that the DIO, some of the DIO have a very special function. SCL.
Yeah, the A5 is SCL. So we need this one.
I know that this is a SCL here. Up to the 13 SCL. Anyone have the Arduino board? No? You can check out, this is a SCL here. Yeah. So you can use this one for the connection. I mean, in the right side, the upper bar is a SCL. Let us to open let me check.
But I tried a long time and it didn't work.
Sorry, let me check. Yes. Here. So you can find the SCL SDA here, and you can choose the digital one, 0 to the 13 for the LoRa. Okay, and I'm not sure the A1. Actually, I use this for maybe the SD card or some of the digital. This is the digital communication protocol for the sensor. But 你们其他有没有这个问题？Okay, maybe if you still have a problem, we can find some time for the discussion. Okay. And one thing is that make sure that your LoRa can transmit from the slope, and should be at least 80 to 90% of the successfully transmission. Okay. And by the way, I would like to say, if you still have the problem, please let me know with the LoRa transmission. Okay. And finally, you should have the time history on the ThinkSpeak at least more than 2 or 3 weeks. Okay. And of course, I already showed you the MQTT in the first. So we already finished this part from the LoRa WAN with the no-red and plus and MQTT. So the other two groups, you need to, if you tried already have the program from the no-red, and you can install that in our lab computer for the 24 hours program。就是你们没有办法自己用 laptop 只要24小时去抓 MQTT 的资料，你们可以把它移植到我的研究室的电脑，这样就可以24小时一直收资料了，好不好 ？Okay, so please make sure you can maybe you can have I think you need to make sure that you can have the MQTT in our lab or in this building. Maybe 100% MQTT can be received, but change to the slope side and with the larger antenna. You should use that. Otherwise, with the original black small antenna, you cannot transmit the data to the MQTT. Okay, you should change to the at least this size antenna. But however, maybe you need to check out with the shorter cable, because the original cable may be up to the 3 or 5 meters. But you can find if I have enough power from the Arduino, there is no use to transmit the data through the very long cable to the antenna. So maybe you need. So maybe Ferry, you can help. Or half-meter cable for the connect your Arduino. I mean the LoRa chip to the antenna. Okay. So if you have any problem, please tell me. Okay, and I can help you to some of the detail, but please quickly. You need to have more than 2 or 3 weeks of time history for the presentation. Okay, any questions? So the next week, everyone please prepare maybe 5 minutes for the IT monitoring website. Or you can find Taiwan or other countries' website, and each one 5 minutes, maximum. Okay, and the next week we will have a site visiting, and the next is the holiday, and so in the beginning of the July, the final week, we will have a presentation of the final project. Okay, so you guys, I already asked you to upload the report, the PowerPoint, and the source code. And in the report or the presentation, you need to show every group 10 to 15 minutes, including the demonstration. You need to show your idea, your purpose, and your methodology, and what you've done in the detail. Okay, and of course, if you have an extra, like just I say, if you try to have the monitoring with the GPS, this is the bonus for your final project. Okay, any idea can be bonus, extra bonus for the final project. Okay, so in our final project, everyone should include the minima, including the tilt, right? The tilt accelerometer. So this is my minimum requirement for each groups, and any other sensors and is extra bonus for your final project. Okay. Okay. See you next week. Yes.
Question about
yes.
ThinkSpeak. First time I was trying to send letter to ThinkSpeak.
Yes. I don't know how often you send the data to the ThinkSpeak.
10 seconds.
3 minutes?
10 seconds.
10 seconds.
Just to
maybe too quick for the ThinkSpeak. Yeah.
Because sometimes
Yes, I see you have some of the data. those missing data, right? This is because this is free, so I think some of the limitation only the sending the data to the TeamSpeak not so quickly. That's fine. Maybe you can choose. You can also have some of the discussion of this. Okay, so maybe you need to. I don't test actually, but maybe 1 minute or 2 minutes. You can test by your own and including to your final project. Okay, sure. So please check out if you can use this.
But the problem is not the pins. I think it's the SPI library.
SPI library.
So
yes.
In the coding.
Yes. Oh, you say the SPI library already defined which pin you need to use.
Maybe, but the thing
you can ask Rick. This is a problem.
Yeah, and we tried this as well, but it didn't.
Really?
So
because
only one you cannot, because there are problems in your